Okay, good morning, everyone. So today we're going to discuss some questions for the review for the quiz that you're going to have on Friday. Okay, so in here we have a couple of questions, and I would like you to just see the notes if you have one. I hope that you have your notes here, guys. And then when you answer all of the question here, make sure that you write down the process of working. Okay, so without the process of working, for example, you only just write down the final answer, although it's probably it's a correct answer, you won't get a full mark. For example, let's say for number one, I give you like 2 marks. Okay, so the maximum point that you can get is 2 points. But for example, you just write down the final answer over here without writing down the process. I will only give you 1 point. But if you write down the process and then you get the final answer correctly, then you will get the 2 points. Okay, so keep in mind that again, you always going to have to write all the process in systematical order. Okay, and just see the notes again and the exercise and some examples that I gave you about how to write down in systematical order. Okay, now let's just start from number one. Here we have calculate 3 plus 5 times 6. Okay, remember guys that we have the bitmask concept, right? In the classroom we have already discussed the bitmask concept, so you need to see which one do you need to do first. We have addition and we have a multiplication. And then if we go here again, the bitmask stands for, the B stands for brackets, I is for index or power, and then DM here is division and multiplication. AS means addition and subtraction. And here we have addition and we have a multiplication. Since the multiplication comes first before the addition, so you do the multiplication first. So this is how you do it. You write down exactly below that. So since you are doing this one first, 5 times 6, 5 times 6 is 30, right? So you write down 30 exactly below this process, right? This 5 times 6. And then since we haven't done anything with this 3 plus, right, you rewrite that again over here. Okay, can you see what happened here? We are doing this and then just changing into this. Okay, and then since you only have like one more process, 3 plus 30, that just equals to 33. That's it. Okay, so you need to write it down like this, like downwards. Yeah. Okay, let's go to the next one. Here we have 10 plus 7 times 2. It's the same thing, right? We have an addition and then we also have a multiplication. So we're going to do this one first, right? 7 times 2. 7 times 2 is 14, right? Then equals to 14 exactly below this. And then we haven't done anything with this one, so rewrite that again. So 10 plus. And then because we only have like one operation here, which is this addition, so just add 10 plus 14, which is equals to 24. Okay, let's go to the next question again. We have 8 plus 12 divided by 4 minus 5. Then again, guys, we have addition, we have division, and then we have subtraction. Then again, if you go to the bitmask concept, we're going to do the division first. So this one is the one that we're going to do first. So that will be equals to 12 divided by 4 is 3. So again, just write down the result exactly below this process, right, which is 3 over here. And the other, because we haven't done anything with this guy and this guy, right, so just rewrite them again. So there will be 8 plus over here and then minus 5. And since it's just addition and subtraction, so we can just like do all of them at once if you want, but if you want to do it one by one, that's fine. Okay, for example, if you want to do the 8 plus 3 first, just do that if you want, and that will be equals to so the 8 plus 3 is equals to 11, right? So this is 11 exactly below that, and then this is minus 5 is still over here because we haven't done anything with that. And then the last one is 11 minus 5 is just equals to 6. Okay, there we go. Okay, next one is number yeah, the next question, which is D. Now we have 24 divided by bracket 6 minus 4 and then plus 3 again. Bitmass, B comes first, bracket, so we're going to do the bracket first, this one first, right? And if we do that operation, 6 minus 4 is 2, so it's right down to over here. And then we haven't done anything with this one and this one, right? So again, rewrite them exactly below them. So 24 divided by this and then plus 3. Okay, the next one here we have a division, right? So we do this first, division, and then we add them. So there'll be 24 divided by 2 is 12, exactly below it, and then plus 3, we haven't done anything with this, so rewrite them again, okay? And then the last one is 12 plus 3, which is equals to 15. Okay, next one is E. 3 times 6 minus 8 squared divided by 4 minus 7. Okay, now again, bitmass, BIDMAS, right? So bracket, we don't have any bracket. And then I stands for index. Index is power. So index is this guy over here, right? So that 8 squared. So you are going to do that first. 8 squared is just 8 times 8, which is 64, right? So write down 64 exactly below that. Okay, the other, we haven't done anything, so just rewrite them again, right? So that 3 times 6 minus and then divided by 4 minus 7, right? So notice that you're only changing the 8 square because we're doing that first, the index first. Okay, the next one here, we have division and multiplication. So when you do division multiplication, you only need to, this is actually, they have the same level, but you do it from the left to the right. So for example, in here we have a division and we also have a multiplication. So you're going to do the process from the left to the right first, because you see from the left to the right you see a multiplication first, so you do the multiplication first. Okay, so let's just multiply that. 3 times 6 is 18, so I'm gonna write down 18 exactly below that. 18, this one becomes 18, and then the other, I'm just gonna rewrite them again like this, right? Here we go. Okay, the next one is, maybe I'm gonna highlight that a little bit, guys. So this 3 times 6 becomes 18, yeah? Okay, the next one is, we have subtraction. We have another subtraction, but we also have a division, right? So division, and here that's 6 minus 64 divided by 8, or just like this one over here, right? So minus 64 divided by 4. Okay, minus 64 divided by 4 is 16. So we're going to write down exactly below that. This is 16. This is minus, yeah? This is minus. This one is negative. 16. And then that 18, we haven't done anything with that. And then this is 7. Okay, so this is the subtraction, so you only need to subtract, right? 18 minus 16 is 2, so I'm going to do this one first. 18 minus 16 is 2, so I'm going to do 2 over here. And then minus 7. And then just subtract 2 minus 7, which is equals to minus 5. Next question, F. 72 divided by bracket 7 times 2 minus 8, and then bracket again, square plus 5 square minus 11. And again, guys, you just write down the bitmass, BIDMAS, right? So we're going to do the B first, the bracket, which is this guy over here, right? So we are going to focus there. So in the bracket, we have multiplication and subtraction. So we do the multiplication first, and then we do the subtraction, okay? So let's do this one first. That's 7 times 2, which is 14. So I'm going to write down 14 over here. And the other, just rewrite them again. Okay, so it's still in the bracket, guys, because we haven't done anything with the negative 8, right? So plus 5 square minus 11, okay? Okay, the next one is, we still have a bracket, right? So this bracket over here. So let's do the bracket again. 14 minus 8 is 6. So we're going to write this down as equals to 72 divided by, in here we have 6. And then we have squared, right? And then because the square is still there, right? So this is a square, because I don't need to write down the bracket anymore, because it only has like one thing over here, which is 6, right? So just write down 6 over here, and then the square, this one, the square is still there. And then we still have plus 5 square and then minus 11. Okay, so we're done with the bracket. Now we go to the index, right? So I is for index. Index, we have 2 of them, so we can do them all at once, like this guy and this guy. We go all at once. So 6 square is 36, so write down over here 36, and 5 square is 25. So yeah, like that. Okay, so the 72, so just rewrite them again. 72, and then minus 11. So yeah, again, so just make sure that you do not left anything behind. Okay, so the next one is the we have done that one. We're going to do the division or multiplication. In here we have a division, which is over here, right? 72 divided by 36, and that'll be just equals to 2. So just 2 put over here, and then plus 25, and minus 11 is still there because we haven't done anything with that. Okay, the next one here we have addition and subtraction, so you can just like do it from the left to the right. So we're going to do the 2 plus 25 first. 2 plus 25 is 27, so write down 27, and then minus 11, and then just subtract them. You will get 16. Okay, moving on to the next question. Andy has 8 pencils, Danny has 11 pencil, and Booty has 9 pencil. Write an arithmetic operation to know how many pencil they have in total. So if we say total, means that we only need to add, right? So you only need to add all of these numbers, right? 8, 11, and 9, because all of them are pencils. I mean, like, they have the same pencils, right? So just write down the operation, which is like 8, and then plus 11, and then plus 9. Remember, you need to write down the process. Just write down 8 plus 11 plus 9, and that will be equals to, you can again guys, if you want to add it one by one, it's fine, or if you want to add all of them at once, it's also fine, right? So for example, I'm gonna add this one first. 8 plus 11, 8 plus 11 is 19, right? And then plus 9 over here, and then add them together, and then you will get 28. Now for this question, because it is like a story problem or word problems, most of the time you will have to write down the units, right? In here, the units or the thing that we are calculating is pencil. So you can just write down the conclusion is in total, right? In total, they have 28 pencil. So this is also going to be very important. I am not going to give you a full marks or the maximum point if you do not write down this conclusion. If you just write down until this one here, so I will minus your mark a little bit, but if you write down also the conclusion in sentence, then I will give you a full marks or a full points. Okay, number 3, this is actually the same thing. Charles has 15 pens, Earl has 12, and Jack has twice as many as Earl's pens. And then write an arithmetic operation to know how many pens they have in total. Then again, guys, you only need to write the numbers, right? So the first one is Charles has 15 pens, so it's 15, and then Earl has 12 pen, which is plus 12, and then Jack has twice. What does twice mean? Twice means to multiply, right? So you're going to add with the number of Jack's pens, which is twice as many as Earl. So Earl has 12, so which means that Jack has 2 times 12. Can you see that this twice as many as Earl's pen is 2 times 12, because twice means 2, right? And then Earl's pen is 12, so this is 12 over here, right? So you write down like this. Okay, and then you can write this down as equals to, again guys, this is using the bitmass concept. You're going to do this one first, right? 2 times 12. I'm just gonna write down 15 plus 12 over here. We don't have to do anything with that. 2 times 12 is 24, and then again guys, if you want to add all of them all together, that's fine, but if you want to add this 2 first, that's also fine. Okay, 15 plus 12 is 27, right? 27 plus 24, and then that'll be equals to 51. And then again, guys, because this is a story problem or word problems, you need to write down the conclusion. In here, they have 51 pens in total. Okay, for number 4, Ken bought some stationery in a store. He bought 20 books, 15 pencils, and 10 pens. So I'm gonna highlight that a little bit. 20 books, and then 15 pencils, and then we have 10 pens. Okay, now if the price of a book is 12,000 rupiah, so this is for the book, right? So the cost of one book. And then a pencil is 2,000 rupiah. This is the pencil. And then the pen costs four times. A pen costs four times as the cost of a pencil, right? So, and then the question is, write an arithmetic operation to know how much does Ken has to pay all the stationery that he bought. Okay, now we can actually do it one by one if you want. For example, you want to write down, okay, how much money does Ken must pay for the book, for example. Okay, so for the book, for example, that'll be just equals to 20 because we have 20 books, and then multiply that with 12,000, right? Because we know that one book costs 12,000. Then if he bought 20 books, just multiply them like this, right? And then for the pencils, right? And then for the pencils, because he bought 15 pencil, that'll be 15, and then multiply by the price of one pencil, which is 2,000. Just write down this like this. And then the last one is for the pen. Since we know that he bought 10 pen, but in here it said that the pen costs four times the cost of a pencil. So in here you need to write down 4 because it said 4 times the cost of a pencil. The cost of a pencil is 2,000. So the cost is 4 times 2,000, right? So this is the cost of a pencil of a pen because it said it's 4 times of the cost of a pencil, right? So it's 4 times. Again, where do I get this 4 over here? This 4 is from here because it said 4 times. Where do I get this 2,000? Because it said that the cost of a pencil, and we know the pencil costs 2,000, so it's 2,000 over here, right? And then you can just like add all of them, right? So if I want to write this down in like in a one line, that will be, so the total price or the total cost is just equals to 20 times 12,000, right? And then add that with 15 times 2,000, and then add them with 10 times 4 times 2,000. Okay, then again, guys, if you don't want to write down like this, that's fine, no problem. If you want to just like, for example, do it one by one, for example, I'm gonna erase this first. Okay, if you want to do it like one by one, okay, I'm gonna calculate for the book, for example, like 20 times 12,000, that'll be 240,000. That'll be 240,000. That's for the book. And then for the pencil is 15 times 2,000, that'll be 30,000, right? Okay, and then this one here, 10 times 4 times 2,000, that'll be equals to 80,000. Is it? Yeah, yes, it is. Okay, so which means that we can actually do it like this if you want, guys. You don't really need to write down in like one line. You can also do it like this. It's up to you, actually. And then again, guys, you only need to add, okay? Remember how to add, if you still remember. Okay, so this is like 0, 0 plus 0 plus 0 is 0, and then 0, and then another 0. Okay, and then 4 plus 3 is 7, 7 plus 8 is 15, so 5 over here, and then put 1 over here, and this is 3, and then here we go. Okay, and then again, guys, because this is a story problems or word problems, you need to write down the conclusion. So the conclusion is Ken must pay, has to pay RP 350,000 to bought all the stationery. Okay, for number 5, we're going to talk about the highest common factor and the least common multiple, or the HCF and the LCM. Okay, so there are many ways on how to do this, guys. You can choose your method, but make sure that you write down the process. Okay, so I'm gonna show you for number 5A the method that I taught you. There are 3 methods that I taught you, but if you have other method, that's fine. Then again, guys, as long as you write down the systematical process, that is okay. Okay, so in here we have find the highest common factor of these two, right? 6 and 8. If I want to find out the highest common factor, so I'm gonna list the factor of 6 and 8. Okay, the factor of 6 and 8, the factor are 1, 2, 3, and 6, right? Because we know that 6 are divisible by 1, 2, 3, and 6, okay? And then 8, the factors are, so I'm going to write down factors here, okay? Factors. So 8 are 1, 2, 4, and 8, because we know that 8 are divisible is divisible by 1, 2, 4, and 8. So if we're talking about the highest common factor in here, the highest common factor, so you see the numbers in here that are the same, but the one that is the largest, right? So 1 are the same, yes, and then 2 are the same, and then we don't see any other number that are the same, right? So since the largest number is 2 from the factor, so the highest common factor of 6 and 8 is equals to 2. Okay, so the next one is the least common multiple. For the least common multiple, you are going to write down the multiple of 6 and 8. Write down the multiple 6 and 8, which is 6 and 8. Okay, so I'm gonna write down like 6, and then the next one is 12, right? Because the multiple of 6 is 6, and then 12, and then 18, so on, right? So I'm gonna do it one by one. Okay, so 8, and then 16, and then 24, and then this is also 24. Can you see that we have the same exact number? As long as you get the first a number that are the same from the multiple of both of them, then that is the lowest common multiple. So the LCM of these two numbers, 6 and 8, it just equals to 24. Okay, so this is the first method. Okay, the second method is we can use the three factors. Okay, so I'm gonna make this a little bit smaller, guys. Okay, the second method is we're going to use the three factor. Now, to use the three factor, let's write down 6 and 8 as a prime factorization. So 6, 2, and then 3. And then the 8 is going to be 2, divided by 2 is 4, divided by 2 is 2, for example, like this, right? So I can write down 6 as 2 times 3, right? 2 times 3. And then 8, I can write down as 2 to the power of 3, because it's like 2 times 2 times 2, right? 2 times 2 times 2. Now, to find the highest common factors from this one, the highest common factor, you need to see the number that are the same, and then with the lowest power. Okay, now we can take 2 because we have 2 over here, and then we also have 2 over here, right? So both of them has 2 as the prime factorization, and then we have 2 over here, and then we have 2 over here, but this one is to the power of 3. So to find the highest common factor, we take the number that are the same but with the lowest power, which is this one over here, because this one has a power of 1, right? So that's just equals to 2. Now we do not take the 3 because 8 doesn't have any factor of 3, right? So the highest common factor is just 2. Okay, and as for the LCM, or the lowest common multiple, now again, if you see this same number like this, we have 2 and 2, but this time you take the highest power, which is this guy over here, right? So that 2 to the power of 3. Okay, but we're not done yet for the LCM, since we have another factor, which is 3. So this one doesn't have any 3, but that's fine for the LCM. Just take it because this is the only 3 that we have, so just write down 3. Okay, so if you calculate this, 2 to the power of 3 is 2 times 2 times 2, which is 8, right? 8 times 3, which is equals to 24. As you can see, we have the exact same answer, right? Okay, so you can choose one of these two methods if you want. Actually, there's one more, but yeah, you could just like use one of them, okay? Okay, so I'm gonna skip B. I would like you to do it by yourself. I'm gonna go to question C. So with the same method, I'm going to use the prime factorization this time. 36 and 24. So 36 divided by 2 is 18, divided by 2 is 9, divided by 3 is 3. And then, which means that 24 is divided by 2, you get 12. Divided by 2, you get 6. Divided by 2, you get 3. So I can write down 36 as 2 times 2 times 3 times 3, or 2 to the power of 2 times 3 to the power of 2, right? So 2 times 2, and then 3 times 3. Okay, so that is 36. Now we have 24. 24 is 2 times 2 times 2, right? We have 3 of that, so that will be 2 to the power of 3, and then times it with 3. Okay, now to find the highest common factor, as I said before, guys, you take the same number, the same base, yeah, with the lowest power. We have 2 over here. We also have 2 over here. Now take the one that has the lowest power, which is this one, right? So the lowest power is this one because this is 2 to the power of 2. Yeah, don't take this one because that's 2 to the power of 3. That's bigger, right? So that is 2 to the power of 2. But we're not done yet because we also have another prime factors, which is 3, which is 3. This is also 3, but this is 3 to the power of 2, and this is 3 to the power of 1, right? So we don't see any number here. Actually, we have, which is 1, and which means that, again, we are going to take the one that has the lowest power, which is this one over here. That's 3, yeah. Okay, just multiply this. This is 2 times 2, which is 4. 4 times 3 is equals to 12. So that is the highest common factor. And for the LCM, the other way around. So previously you are like taking the lowest power. Now we're going to take the highest power. So from these two, the highest power is this one. So it's 2 to the power of 3. And then for this one, the highest power is this guy, 3 to the power of 2. Okay, so if you calculate it, this is 8, and this is 9, and that'll be just equals to 72. Okay, I'm gonna skip D. I would like you to try by yourself. And let's go to the next number. I'm gonna skip A and B. I'm gonna go to C. Yeah, the question C. Actually, for this question, because it's actually the same thing, right? So you're going to find the highest common factor and also the least common multiple. But the only difference is for the previous question, we only like take two numbers, right? So 28 to 35, for example, 36 and 24. But this time we have three of them, right? Like 4, 6, and 8, 6, 12, and 24, and then 32, 48, and 17, and so on, so on, so on, right? So, but the concept are actually the same thing. I mean, like, they have the same exact concept. So I'm going to show you for question C here. We have 32. What's the LCM and HCF of 32, 48, and 72? Okay, now let's do the prime factorization again. Let's start with 32. So 32 and then divided by 2, that'll be equals to 16. And then divided by 2 again, you get 8. Divided by 2 again, you get 4. Divided by 2 again, you get 2. Okay, that's for 32. Now we go to 48. 48 divided by 2 is 24. Divided by 2 again, you get 12. Divided by 2 again, we get 6. Divided by 2 again, we get 3. And then the last one is 72. 72 divided by 2 is 36. Divided by 2 again, we get 18. Divided by 2, you get 9. Divided by 3, you get 3. Okay, now just write down all of the you can I mean, like, the prime factorization. So now 32 here are the multiplication of 2 times 2 times 2 times 2 times 2, right? So we're multiplying 2 5 times. So 32, that will be equals to 2 to the power of 5, right? Because we're multiplying 2 5 times. The next one is 48, right? 48 is the multiplication of 2 times 2 times 2 times 2 times 3, right? So that'll be 2 to the power of 4 multiplied by 3, right? So because we are multiplying 2 4 times, that's why it's 2 to the power of 4. And then we still have this 3 over here, and yeah. And the last one is 72. And that'll be the multiplication of 2 times 2 times 2 times 3 times 3, okay? So that'll be 2 to the power of 3, and then multiply by 3 to the power of 2. Okay, there we go. Now, again, we are going to find the LCM, the ATF and LCM. We're going to go to the ACF first, highest common factor. So, again, for the highest common factor, you need to find the same number, okay? The same base, yeah? The same base is 2 because all of these three numbers has 2, right? This the factor prime factorization of 2. Now, for the highest common factor, you need to take the lowest power. The lowest power here is this guy over here, right? So because the power is 3, the other is 4 and 5. So you take the one that has the lowest power, which is this one. That is 2 to the power of 3. So the HCF is 2 to the power of 3. and then we don't take I mean, we're done actually, because we know what, because we cannot take the 3 because we have 3 over here, we have 3 over here, but we don't have any 3 over here, right? So make sure that for the highest common factor, you will have the same exact number for all of the numbers, right? So if we have, for example, this is times 3, then you can take the 3, but because we don't have it, so don't take it. So the HCF, or the highest common factor, is just 2 to the power of 3. 2 to the power of 3 is just 2 times 2 times 2, which is equals to 8. Okay, so that's the first one. The next one is the lowest common multiple. Okay, so the lowest common multiple, again, guys, you see, if you see the same number like this one, 2 times 2, 2, 2, and 2, right? So this is 3, right? Now, you are going to take the highest power, right? Previously, you're taking, for the highest common factor, you're taking the lowest power. For the least common multiple, you're taking the highest power. So which means that we're going to take this guy over here, right? So that'll be 2 to the power of 5. Okay, now we're not done yet, because we can also take the 3. So remember, notice the difference between the LCM and the HCF. For the LCM, if we have a difference, I mean, like, we only have it in like one place, you can take it as long as it's there. So this is 3 and this is also 3. So it doesn't matter if you don't have any 3 over there, right? So just focus on the 3. So again, we're going to take the number with the highest index, which highest power, which is this one, 3 to the power of 2. Okay, so that'll be multiplied by 3 to the power of 2. Okay, now if we calculate this, you can use a calculator, guys. So 2 to the power of 5 is 32, and then 3 to the power of 2 is 9. So just multiply this number, and that'll be equals to 288. So you can try the same method with this question, okay? Okay, moving on to the next question, which is going to be about fraction, decimal, and percentage. In here, we have an addition of a fraction. Now remember, in addition and subtraction of fraction, what we need to see first is the denominator. If we see that the denominator are the same, you can just add the numerator. For this question number 7a, since we have the same exact denominator, which is 5, so you can just add 1 and 3, because this is just an addition, right? So 1 plus 3. 1 plus 3 is equals to 4. Now remember that you don't add the denominator. The denominator is just that, okay? So it's just 4 over 5. That's it, okay? So okay, or you can just write down, okay, if you want to write down the process, they'll be just like 1 plus 3 over 5, right? Because you only need to add the numerator. That will be just equals to 4 over 5. That's it, okay? Okay, the next one is this one here. And this is also the same thing, right? So you can see that we have the same exact denominator. If we see that they are the same, then you can just add the numerator, which is just, this is 1 and 3, so it's just 1 plus 3 equals to 4 over 8. But be careful, you need to write down the final answer as the simplest form of fraction. So in here, we can simplify this fraction, since both of these number, right, 4 and 8, has the highest common factor of 4. So we can divide both of them by 4. Divide this by 4, you get 1. Divide this by 4, you get 2. So this is going to be the final answer. If you answer it like this, right, so you won't get a full marks or a full point. So you will get the full points if your answer is this one, okay? It doesn't mean that your answer is incorrect. You're correct, but you haven't finished it yet until the simplest form of fraction. Okay, now let's go to the next question. Here we have a mixed number, 2, 1 over 3 minus 1, 2 over 5. So my suggestion is, guys, you need to convert the mixed number into a what they call improper fraction. So how to convert that? So it's like 2 1 over 3. If you want to convert this into a improper fraction, you just multiply the 2 with the 3, right? And then add it with the 1. So it's just multiplication and addition. 2 times 3 is 6. 6 plus 1 is 7, right? So that'll be 7. And then the denominator doesn't change. It's just 3. So that'll be, this guy becomes 7 over 3. Okay, the same thing with this one, right? 1, 2 over 5. So 1, 2 over 5. You multiply 1 with 5, right? And then you add it with 2. 1 times 5 is 5. 5 plus 2 is equals to 7. So there'll be 7. And then again, guys, the denominator doesn't change. So that will be just 7 over 5. Okay, so that's the first one. Now, we see here that we do not have the same exact denominators. Now, how can we add or subtract this? Okay, so again, guys, subtraction and addition, you need to make sure that the denominator are the same. Now, for this one, if you don't have the same denominator, then we need to find the LCM of these two numbers, right? Because we have 3 and 5, right? We have already learned about the LCM, right? So the LCM of 3 and 5 is 15. So we need to change, so both of them has a denominator of 15. Now, we can see that from this one here, I'm going to change this guy, becomes this, where the denominator is 15. So you can see that going from 3 to 5, right, it's just multiply by 5, right? Or 15 divided by 3 is 5, right? So which means that I'm also going to have to multiply this by 5. 7 times 5 is 35. So this is 35. Okay, so the next one is also the same thing, right? So here to here, right? So say 15 divided by 5 is 3. So which means that you are going to multiply 5 with 3, right? Because 5 times 3 equals to 15. So you're also going to need to multiply this by 3, which is going to be 7 times 3 is 21. Now, we have the same denominator, right? So we have the same denominator. Now we can do the same exact method like we did for question A and B. So that will be equals to, so the denominator doesn't change, right? So you only need to do the process of 13 and 21, and it's being subtracted. So it's just 35 minus 21. Okay, 35 minus 21 is 14. So it's just 14 over 15. So that's the final answer. Okay, so I would like you to do the same thing, do the same method, and try for question D. Okay, moving on to question E. Here we have a different form, right? We have fraction, we have mixed number, we have decimal, and we have percentage. Now, my suggestion, guys, is that you need to convert this into fraction, because that is the easiest one. So actually you can use a decimal, but sometimes it can have like a recurring decimal and you haven't learned about it. But that's why my suggestion is that change all of them so that they have the same form, which is a fraction. Okay, so let's do it one by one. So 1 over 2 doesn't change because it is a fraction, just 1 over 2. And then 2 1 over 3, we have already learned on how to convert that into fraction. So this is like 2 times 3, which is 6. 6 plus 1 is 7. So that'll be 7 over 3. And then 0.6 is the same thing as 6 over 10, right? Because we know that in here we have only one number behind the decimal place, right? So it's over 10. So I'm going to give you another example. For example, if I have 0.04, for example, this is 4 over 100. Why is it over 100? Because this number is like 2 places after the decimal, right? That's why it's 100. 100 has 2 of 0, right? So yeah, this is how you change it. Okay, or I can change this again, guys. 6 over 10 can be changed as 3 over 5, since we know that both of these number has the highest common factor of 2. Divide this by 2, you get 3. Divide this by 2, you get 5. Okay, so I'm gonna write down this as 3 over 5. Okay, the last one is 25%. 25% is 25 over 100, right? But remember that percent means over 100, so it's over 100. And you can actually, again, guys, simplify this becomes a 1 over 4 because we can divide both of them by 25. Divided by 25, divided by 25, you get 1 over 4. Okay, now for this one, it's actually the same thing like before, but the difference is that previously we only have like two fractions, right? Two terms, and here we have like four terms. Now we can do it one by one, or we can do it all at once. Now we can do it all at once by finding the highest common, not highest common factor, it's the lowest common multiple or the least common multiple of 2, 3, 5, and 4. Okay, so you can do that, and then or we could just like, okay, we're gonna do this first, and then after that we're gonna do it like this one, and then going to do this one, right? So you can just like, yeah, do it like that. Okay, now in here, guys, actually there's one thing that I actually want you to do is like I would like you to do is that you use your calculator, because you can just actually put this into the calculator, but I would like you to do it one by one. Okay, so like, okay, what's this, and then you write it down over here, and then what's this, and then you write it down over here, and so on, so on, so on, so on. Okay, but I'm gonna do it manually this time. Okay, so I'm gonna just find out the highest the least common multiple of all of these numbers, and that is I think is 60. I think it's 60. Yeah, I think it's 60. Yeah, so that will be over 60, all of them. Okay, over 60. Maybe I'm gonna just write down over here because it doesn't really fit over here. I'm gonna move that a little bit to the left, guys. Okay, so over 60, right? Over 60 plus over 60 and minus over 60, and then plus over 60. Okay, so here you multiply by 30, right? And which means that this is also multiplied by 30, so they will get just 30 because 1 times 30 is 30. Okay, we're done with that one. I'm gonna erase it, and then we go to the next one, which is this one. We have to multiply this by 20, so multiply also this by 20. So 7 times 20 is 140. I'm gonna write down 140 over here. Okay, I'm gonna erase this, so I don't need it anymore. And then the next one is this one here. You multiply this by 12, so multiply also this by 12, you get 36. Okay, the last one is this one over here. You have to multiply this by 15, so multiply also this by 15, you get 15. Okay, now see, we have all of them in the same form, and they have the same exact denominator, right? So we only need to like, okay, just do all of the operation on the numerator, so that'll be just equals to, so over 60, right? That'll be 30 plus 140 minus 36, and then plus 15. Okay, and then again, guys, you can use the calculator to find this one, and then you will get 149. Okay, there we go, right? So if you want to find out whether this is the simplest form of fraction, just write that down in the calculator and then press equals to. If it doesn't change, so this is the final answer. Yeah. Okay, so I have done for question F for you guys. You can just pause the video if you want and see what happened here, okay? Okay, so for number 8, Gwen works in a factory packing cocoa powder per export. She has to take 10 kilogram bags of cocoa powder and pack them into all into small plastic bags. Each small bag holds 1/2 of a kilogram. How many small bags will she need? So this is pretty easy, because we know that this many, so that 10 kilogram needs to be divided into small plastic, which is whole half of that. So the operation is just 10 divided by 1 over 2, right? Because this is 10 kilogram, this is half of kilogram. That's 10 kilogram divided by half kilogram. And as you see that, we know that if we have a division like this is actually, we can like swap the 1 and 2 and then change the division into a multiplication. So this is multiply by 2 over 1. That will be just equals to 20. So and again, guys, because this is a story problems or word problems, write down the sentence as a conclusion. So she will need 20 small bags. That's it. Okay, number 9. 3 bells toll at a regular interval of 4 minutes, 12 minutes, and 15 minutes respectively. Given that they toll together at 11:45 a.m., what time will they next toll together? So we need to find out the time they need to, so that they are going to toll at the same time. Now in here, if they are, the concept of finding them is just the multiply, right? Because we know that it's like the first one is every 4 minutes, there'll be like 4 minutes, and then 8 minutes, and then 12 minutes, so on, so on, so on. The second one will be 12 minutes, there'll be like 12 minutes, and then 24 minutes, and so on, so on, so on. The same thing with this one, right? 15, and then 30, and so on, so on, so on. So which means that this is, for this question, we're going to find the lowest common multiple, right? So we're going to find the lowest common multiple or the least common multiple, because it said that given that they are going to so actually we have like a keyword in here, right? Together again, right? No, together. So it means that we're going to find the LCM. Okay, now let's find the LCM of these two numbers, 4, 12, and 15. Let's use the prime factorization. So 4 is like 2 divided by 2, and then we have 12, and that will be 2, and then divided by 2 is 6, divided by 2 is 3, and the last one is 15. That'll be divided by 3, which is going to be 5. So I'm gonna write down 4, that'll be equals to 2 squared, and then 12 is going to be 2 squared times 3, and then 15, that'll be 3 times 5. Okay, so which means that the LCM is, now we can see that the 2 to the power of 2, they are both the same, so just take one of them. So it's just 2 to the power of 2, and then we have 3, and then this one here, right? So they're also the same, they have the same power, so it's just 3. And then since this is LCM, we also need to take the 5, so times it with 5. Okay, so 2 times 2 to the power of 2 is 4, so 4 times 3 times 5. 4 times 2 is 12, 12 times 5, which is equals to 60. So which means that they will toll together again after 60 minutes. Now, this is not the final answer because the question is what time, right, after 11:45. So it means that it will be 11:45 plus 60 minutes. So 60 minutes is the same thing as 1 hour. So that'll be 12:45, but remember this is like AM, now it's going to be PM. Okay, now for number 10, a Greg has 3 pieces of rope with lengths of 350 centimeter, 244 centimeter, and 504 centimeter. He wishes to cut all the 3 pieces of rope into smaller pieces of equal length, such that there is no leftover rope. What is the greatest possible length of each of the smaller pieces of rope? So in here, because we're looking for a smaller number, right, a small number, so we're going to find the highest common factor. Now we're gonna do the same exact thing like before, guys. So we need to like write down the prime factorization of all of these numbers. Okay, so let's start from 350. So 350, we can just divide this by 2, you get 175, and then divide this by 3, you get can we divide this by 3? I don't think so. Divide this by 3, you get, no, you can't divide this by 3, you can divide this by 5, right? Divide this by 5, you get 35. Yeah, 35. And divide this by 5 again, you get 7. Okay, so this is the 350. The next one is 224. Divide this by 2, you get 112. Divided by 2 again, you get 56. Divided by 2 again, you get 28. By 2 again, you get 14. By 2 again, you get 7. And the last one is 504. Divided by 2, you get 252. Divided by 2 again, 126, I think. Is it 125? 125? Yeah, 126. Divided by 2 again, you get 63. Divided by 3, you get 21. Divided by 3, you get 7. Okay. So these are the prime factorization. I'm going to write down one by one. So 350 are the multiplication of 2 times 5 times 5 times 7. And write down as 2 times 5 to the power of 2 times 7. And then 224. That is the multiplication of 2 times 2 times 2 times 2 times 2 times 7. 1, 2, 3, 4, 5. So it's 2 to the power of 5 multiplied by 7. And then the last one is 504. That'll be equals to 2 times 2 times 2 times, and 504 is equals to 2 times 2 times 2 times 3 times 3 times 7. Okay, so that'll be 2 to the power of 3 times 3 to the power of 2 times 7. Okay, now we're looking for the highest common factor. Now we see the number that have the same base, which is the first one is 2, right? So all of these three numbers has a factor of 2. Now for the highest common factor, you are going to find the lowest number, which is this guy over here, right? Because this is to the power of 5, this is to the power of 3, this is just 2 to the power of 1. So just take that one. Okay, now the highest common factor is equals to 2. Okay, we're not done yet because we can actually see another number that are the same, which is this guy, right? So all of these three numbers have 7. So multiply that by 7. Now, we do not take the 5 because we don't have any 5 over here, we don't have any 5 over here, so don't take it. Now, we do not also take the 3 because we don't have any 3 over here and over here, right? So don't take the 3. So that's just 2 times 7, which is equals to 14. So, which means that the question A, so the greatest possible length of each of the small pieces is 14. 14 what? It's 14 centimeter, right? So again, guys, you need to write down in sentence. So the greatest length is 14 centimeter. That's it. You don't really need to like write it down in like a very long sentence. Just make sure that it is clear. Okay, so the next question is, how many smaller pieces of verb can he get all together? Meaning that we're going to cut all of these ropes, right? For each of the cut is 14 centimeter. So there are a couple of ways on how to do it. If you can like, okay, so if I want to cut this into like smaller pieces, in which the smaller pieces is 14 centimeter, how many cut will I get, right? One by one. Or you can just like add all of them together and then divide it by 14, right? So you can use any method you want. So for this method, I'm gonna just like add all of them, okay? So if I add them, so that'll be the total length. So I'm gonna write down the total length. The total length of the rope is 350 plus 224 plus 504, and that'll be equals to 1078. So to answer question B, so smaller pieces, yeah, this is the smaller pieces are just dividing 1078 by 14. Then again, guys, since you are allowed to use the calculator, just use the calculator, and that will be just equals to 77. Then again, you need to write down the sentence, yeah. He or she. Oh, Greg, it's he. Yeah, he can get 77 smaller pieces of rope. Okay, so for number 11, I'm not going to give you the answer, but I'm going to tell you that number 11 has the same exact concept as number 9, right? So in here, you're going to find the LCM first, right? And then just add that with the amount, the time that is they start together. For example, like this one here's like uh we have like three numbers here, 4, 6, and 8, right? Find the LCM, and then you'll, I mean, like the next time that they will work together again is just like at this date by the number of days that you get for from the LCM. Yeah, that is for number 11. I should you should try it yourself. Okay. So for number 12 is also the same thing. I'm not going to give you the answer, but this is the has the same concept as number 10, right? So in here, right? So this time you're going to find the highest common factor, and then you just divide it one by one, right? So just find the highest common factor of 48, 72, and then 36, right? And then which means that that's will be the number, the maximum number of gift bag that can be packed. And then for the number of each item, for example, if the for example the what do you call it, the highest common factor, for example, is 8, for example. So which means that just divide this by 8, divide this by 8, divide this by 8, right? Yeah, so that's just the example, but you need to find out the LCM. Okay, so number 11 and number 12 is actually has the same concept as number 9 and number 10. Okay, now the last one, number 13. Actually, I'm not going to give you any clue for this one. I would like you to analyze yourself. This is a challenge question, okay? A challenge question. I would like you to challenge yourself and try to understand the question, and then try to see what concept should you use to solve the question. For example, is it the highest common factor, or is it the lowest common multiple? Okay, so I'm gonna give you a challenge for this one. If you able to answer this question and explain it to me later, I will give you a plus point. Okay, okay guys, good luck.